Okay, this video will be part 2 on the lesson on reflections. So in part 1, we went through the concepts of vertical reflections and horizontal reflections. And what this part 2 is going to be is essentially applying the concepts that we learned in by answering questions. So this first question is very similar to the one we did, but let's go through this one and then we'll get to just more questions. Okay, so what this question says, number 2, it says here's the graph of y is equal to g of x. So the original function is y is equal to g of x. And then they say sketch the graph of the transform function, which is y is equal to negative g of x. Okay, so you need to be able to look at that and you need to be able to say, well, is this a horizontal or is it a vertical reflection? And if the negative apply to the x, that would be a horizontal reflection. If the negative is outside, that is going to be a vertical reflection. So what happens, remember I said, always draw yourself like a little Cartesian plane if you need to. And a vertical reflection, if we have a point here, a vertical reflection is an up-down move. So the point would go here. And then what would happen with a vertical reflection is x comma y, our new coordinates in a vertical reflection is x stays the same and y becomes negative. So what's happening with vertical reflections, the replacement notation is y is being replaced with negative y, right? So if I took this original equation here and I put a negative in front there, that would be a vertical reflection about the, and then which axes are we in? We are crossing the x-axis. So it's a vertical reflection about the x-axis. When you guys get really good at this, you'll just be able to look at this and say, okay, the x is, or sorry, the negative is outside of the function. That is a vertical reflection. Like when you get really good at that, you'll say vertical reflection, and then you'll just write your mapping. XY is going to be mapped to x comma negative y. Okay, so what it says is sketch the graph of the transform function. So what we need to do is we need to find points on our original graph, and then we're going to transform those points. So I'm just going to write it over here. So again, x comma y is going to x comma negative y. So I'm going to take 0. So this point here, I'm going to call A. And that point, x is 0, y is 2. Then B, I'm going to take this guy here, and that point is at 1 comma 6. C, I'll take this guy here, which is at 2 comma 4. And point D, I'll take that guy there, which would be at 3, x is 3, y is 2. And the last point I'll transform is E, which I'll just take that guy there. So I just pick good points on my graph, 4 comma 6. Okay, my transformed points, all I simply have to do for this, I am doing a vertical reflection. So this point is going to be reflected down. So my y coordinates change. So 4 comma 6 would become 4 comma negative 6. And that would be E prime, right? A prime would be 0 comma negative 2. B prime would be 1 comma negative 6. C prime would be 2 comma negative 4. D prime would be 3 comma negative 2. So I've got all of my new coordinates on my transform graph. So let's plot those. So A prime would be, so 0 comma negative 2. So there's my A prime. B prime, C prime, D prime, and E prime. So A prime, this is B prime, Okay, my new graph would be this. That would be my transformed graph. Okay, are there any invariant points? So remember that invariant points are points that remain the same, and it actually is a little bit off in my graph, but you need to remember from the last lesson that when we undergo a vertical reflection, the invariant points are the x-intercepts, right? So in a vertical reflection, invariant points are the x-intercepts. So actually this guy right here is my x-intercept. That point there would be invariant. And that point is approximately negative 0.25 and 0. So you wouldn't have to, if this was an actual like exam question, if I said what's the invariant point, you would just say it's the x-intercept. Because it's not a nice invariant point, you wouldn't have to give it to me. Okay, let's look at the next question. Okay, so the question says, write an equation for the image of each function below after. So the first one is a reflection in the x-axis. So again, here's my x-axis, here's my y-axis. So if my point is there and I reflect it in the x-axis, you say that is a vertical reflection. Now, what happens with a vertical reflection? What was the replacement, right? So the replacement in a vertical reflection is y went to negative y. So it would be x comma y is going to x comma negative y is equal to f of x is going to negative y is equal to f of x, or y is equal to negative f of x. That is a vertical reflection, okay? So what they've done is they've given us g of x, and they said, this is my function g of x. And then they say, well, what would the equation of this image be after a vertical reflection? So this entire thing is g of x. And what we have to do to this function is we have to put, if it undergoes a vertical reflection, a negative in front of my function. So my function for number one is negative 2x cubed plus x squared minus 5x minus 3. If this is undergoing a vertical reflection, your negative goes in front of your function. So the negative 1 would go there. And then what you would do to get your new transformed function is we got to distribute in this negative 1. So my new transformed function of g of x is equal to negative 1 times negative 2 is 2x cubed minus x squared plus 5x plus 3. Okay? So if you were to graph, like on your calculator, this graph, and then you were to graph this guy, that would be a reflection in the x-axis. That would be a vertical reflection. Okay, number 2. A reflection in the y-axis. So a reflection in the y-axis, so let's write number 2 here. If that's my point, that is a horizontal reflection. So number 2, it is a horizontal reflection. X was replaced with negative x. So the mapping was x comma y is going to negative x comma y. And y is equal to f of x is equal to, take out your x and you put in negative x. Y is equal to f of negative x. Okay, so with my function, they give us g of x, right? So they say we're not going to call it f of x, we're going to call it g of x. So g of x, if they want that to undergo horizontal reflection, that's going to be g of negative x. So what that means is within the original function, in every single x value, I need to put in a negative in all of these x values. Okay, so let's write what our equation was. So g of x is equal to, so this was my original equation, negative 2x cubed plus x squared minus 5x minus 3. What we are doing is in our transformed function, we are taking out our x's in this equation and we're going to put in negative x's. So negative 2 negative x cubed plus that x comes out and negative x goes in, and I'm going to square it, minus 5. That x comes out and a negative x goes in, and then minus 3. So now g of negative x is equal to, this 3 goes on the x and it applies there. So negative 1 to the power of 3 is negative, right? So this is negative 2 times negative 1 x cubed, right? So you just have to, just imagine that's a negative 1, and negative 1 to the power of 3 stays negative, but a negative times a negative here will give you a positive. So that becomes 2x cubed. Now, this is a negative 1. Negative 1 squared becomes positive 1. So that becomes plus x squared. Negative 5 times negative 1 here is going to be negative times negative is plus 5x minus 3. That is my transformed function, okay, after it undergoes a horizontal reflection. Okay, next question. The graph of y is equal to the square root of x minus 3 was reflected in the y-axis. So reflected in the y-axis, that is a horizontal reflection, right? Horizontal reflection, x is replaced with negative x comma y is going to be negative x comma y. And then remember, for our functions, y is equal to f of x. If it's a horizontal reflection and the x becomes negative, this is going to be y is equal to f of negative x, right? So the negative inside the function, that is our horizontal reflection. Okay, so it says the graph of y is equal to square root of x minus 3 was reflected in the y-axis, and its image is shown. What is the equation of this image? So I need to take my original equation, y is equal to the square root of x minus 3, and if it undergoes a horizontal reflection, I need to take my x out and I need to replace it with negative x. So within this function here, the x comes out and a negative x goes in. Okay, that is the answer. One thing we have to do though, so students who write this, your answer is correct. I am going to quickly show you something from grade 11 when we did the radicals unit. So remember that we did restrictions on radicals, and you can never take the square root of a negative number. So we said that the restriction on negative x it must be greater than or equal to 0, because you can't take the square root of a negative number. So then if I was to solve for x here and divide that by negative 1 and that by negative 1, my restriction is when you divide both sides by a negative, your inequality sign flips. So my restriction is x must be less than or equal to 0. So I always, with radicals, get in the habit of, this was what they were actually asking for. And then on your diploma, you would actually, if you are given a radical, would need to state what that restriction is. Okay, so that's Math 20-1 radicals. Okay, let's look at this. So this is really, you guys, showing me if you understand this. So I actually consider these three questions more difficult questions, but these just really show who gets this and who sort of is struggling with this. So a few things. They're given the partial graph of y is equal to f of x, and they say that the x and the y intercepts are integers. So what that means is like this x-intercept is 3, that guy is 1, that guy's -2, and this y-intercept would be 2. Okay? So question 11 says the new graph g of x is this graph with a negative in front of the function. So you need to be able to look at that. If the negative is outside of the function, was that a vertical or horizontal reflection? And if the negative is outside of the function, that is a vertical reflection, right? And a vertical reflection, so if we have our point and we do a vertical reflection, the replacement is y is replaced with -y, and our coordinates xy would be mapped to x comma -y. Okay, and remember y is equal to f of x. If it's outside the function, that's going to be y is equal to negative f of x. Right? So all of that I wrote, and I don't really need to. You just need to be able to look at that, and you need to say that is a vertical reflection. Okay, with vertical reflections, what do you remember about the invariant points? So this is going to have to, a question is going to be about invariant points. And remember that with vertical reflections, x-intercepts are invariant. Okay, so what this question is saying is if I take this graph and I undergo a vertical reflection, what would the largest x-intercept of the graph be? So if this undergoes a vertical reflection, so this point's going to go down here, right? This point would go up here. The invariant points, though, would stay. So this stays, and this stays. Those x-intercepts are invariant. So my new graph would look something like this, right? That would be a vertical reflection. So that would be my graph of y is equal to f of x is reflected vertically. What is the biggest x-intercept if it undergoes a vertical reflection? Well, x-intercepts are invariant, so the answer would be D. Okay, I'm going to erase my graph so we could do number 12. So let's erase this guy and let's do number 12. So again, looking at this, now they're saying, okay, we're going to make a new graph and we're going to call this new one h of x. So h of x is going to be this original graph, but they want to replace x with negative x. So if you see that, is that a vertical or horizontal reflection? So hopefully now you're saying, you're getting quicker at this and you're saying, okay, that's a horizontal reflection, right? When x goes to negative x, that's going to be a horizontal reflection um, in the y-axis, right? And so what's happening here is x comma y is going to negative x comma y. And what were the invariant points with horizontal reflections? So horizontal reflections, y-intercepts are invariant. Okay, but let's see what the question is asking. What this question is asking is if this graph undergoes a horizontal reflection, what is going to be the smallest x-intercept of the graph? Okay, so the smallest x-intercept. So we know that this will be invariant, right? That point's going to stay the same on a horizontal reflection. This point here was 3 comma 0. That point is going to go to -3 comma 0, right? Um, this point, which is 1 comma 0, is going to go to negative 1 comma 0. And this point, maybe I'll put this in blue, this guy in blue. And this last one, which was negative 2 comma 0, it's going to go to 2 comma 0. So it's going to go here. So when we undergo a horizontal reflection, the smallest x-intercept, so my new x-intercepts are going to be negative 3, negative 1, and 2. That's going to be my invariant point. The smallest x-intercept is that guy right there, which is negative 3. So your answer is A. Okay, now we're taking this graph again. So I'm going to erase this. We're taking this graph again, and we're doing two different reflections. So we're reflecting it in the x-axis. We're going to undergo a vertical and a horizontal reflection, is what it's showing here. So let's just show that. So what this is saying is that xy is going to go to negative x, right? So x goes to negative x and y goes to negative y. So it's going to undergo horizontal and a vertical reflection. And what the question is asking is if it undergoes both reflections, like if you reflect it vertically and if you reflect it horizontally, the largest x-intercept of the graph is. Okay, so we're dealing with, they want to know x-intercepts. Now, which reflection affects the x-intercept, right? So they're saying, okay, p of x is equal to negative f of negative x. Which reflection affects the x-intercepts? And it's this guy here, right? This one affects the x-intercepts. This does not affect x-intercepts. Right, this is going to be our invariant points. So the x-intercepts are going to be the reflection within the function, which is going to be our horizontal reflection, right? So that's going to be x going to negative x. That's going to affect our x-intercepts. So x, y going to negative x comma y. Okay, so we go back to our graph and they want to know what the largest x-intercept of my graph would be. So again, this point here, negative 2 comma 0, that's going to go to 2 comma 0. And then this point, 1 comma 0, is going to go to negative 1 comma 0. And this point, which is 3 comma 0, is going to go to negative 3 comma 0. So it says the largest x-intercept of graph P, if it undergoes both reflections, we only need to worry about, because it's asking about the x-intercepts, I only need to worry about this transformation here. The largest x-intercept is going to be this 2 here. So the answer for this is 2. Okay. Okay, describe how the graph of the second function compares to the graph of the first function. So before we do this, I just want you to write off to the side y is equal to negative f of negative x. Okay, so if your negative is inside your function, that's a horizontal reflection. And if your negative is outside of the function, that's a vertical reflection. I'm actually going to start with D and E because I think these two are easier to see. And then we will go back to A and B. So what's happening here? Y is equal to 10 to the power of x is being transformed to this. Y is equal to 10 to the power of negative x. I hope what you're seeing here is that x is being replaced with negative x, right? X is being replaced with negative X. So then if I go back up here and I look at my little like cheat sheet that I make, negative X is a horizontal reflection. Okay, so that's all they're asking, like what type of reflection would this be? So y is equal to 10 to the power of negative x is a horizontal reflection of the original function, which was y is equal to 10 to the power of x. Okay, my function is 10 to the power of x, right? That's my function here. So I'm going to put that in a bracket. What they've done is they've put now a negative in front of my function. In front of your function, if the negative goes in front of your function, it is going to be a vertical reflection. Vertical reflection. And if you need to, vertical reflection, what you could write down is y is replaced with negative y. So if this was my original equation, let's take out that y and put in negative y is equal to 10 to the power of x. We know that that's a negative 1. Divide that by negative 1 and this by negative 1. Y is equal to negative 1 times 10x, which is just the same thing as y is equal to negative 10 to the power of x. Okay? Now, these two are a little trickier, but they're questions that are fair to ask. So if we're going from here to here, and then we're going to go from here to here, which one is going to be the vertical and which one's going to be the horizontal? So for example, you guys, we know that vertical is when the negative goes in front of the function. So because these are the same functions, right, and my function is 3x plus 1, let's put a negative in front of the function and see which one would be the vertical reflection. So if I put a negative in front of the function, then I would get y is equal to negative 3x minus 1. This would be my vertical reflection, which is this guy here. So this one is going to be my vertical reflection, and y was replaced with negative y, and that's y is equal to negative f of x, right? So they took this original function and they put a negative in front of it. Now, what they've done here is this is going to be our horizontal reflection. What a horizontal reflection is when they take the x and they replace it with a negative x. So let's take this x out and let's replace that with a negative x. If I do that, I get y is equal to 3 times negative x plus 1, which is y is equal to negative 3x plus 1, which is exactly what they gave me here. So this original to my transformed would be a horizontal reflection. Okay, last question. The graph below the graphs below represent the transformation of the function f of x is equal to x squared. So x squared we know is a parabola, right? So let's draw that. F of x is equal to x squared. That's essentially this graph here. Y is equal to x squared. We know what a parabola looks like from 20-1 quadratics. Okay, then I always like writing my little cheat sheet, and I always like writing y is equal to negative f of negative x. So I always, for like all of my questions, will write that down. And then I know that if it's within the function, that is a horizontal reflection. And if it's outside of the function, that's a vertical reflection. Okay? Okay, so which graph, if this is my original, which it says write the graph of the number corresponding to f of negative x. So f of negative x is going to be a horizontal reflection. So for this first one, they are looking for a horizontal reflection. So what they're looking for this first one is they want me to take this x out and they want me to put a negative x in here. So that would be y is equal to take that x out and put a negative x in squared. What that would be, the new equation, negative 1 squared becomes 1, and then the x squared becomes x squared. So my graph, when it's reflected horizontally, doesn't actually change. Because if you think about it, you guys, this arm here, if I reflect it, it becomes this arm, right? And this arm, if I reflect it, becomes this arm. So a horizontal reflection, the graph itself does not change. So if I scroll through all of these, the one that undergoes a horizontal reflection is going to be this guy here, number 4. Okay, write the graph of the corresponding, the number corresponding to f of x plus 2. This goes back to lesson 1. Was that my k value or my h value? If it's within the function, that's my h value. My h value is negative 2. That is a horizontal translation, 2 units left. So if this is my original function, and I move this 2 units left, which graph would be 2 units left? It would be this guy here, right? Here's my original function, and then 1 unit, 2 units. So my second number in the box would be 5. Okay, write the graph number corresponding to my function minus 2. Hopefully you see from lesson 1 that that's my k value, and my k value is negative 2. That means vertical translation 2 units down, and that would be number 3. Okay, now my negative is in front of my function, so going to my little cheat sheet up here, negative in front of the function is a vertical reflection. Vertical reflection, the negative goes in front of the function. So a couple of things. Maybe I'll just do it down here. So we had y is equal to x squared. That was a parabola. You know that if it's a vertical reflection, that's a reflection in the x-axis. So that's what the graph would look like, which is number 1. The other thing that you could do is we know that y is being replaced with negative y. So take this out and put a negative y is equal to x squared. Negative, or get rid of the negative 1. So divide both sides by negative 1. Negative 1 x squared. If you type in on your calculator negative x squared, you will see the original graph reflected in the x-axis. Okay? And that's when it undergoes a vertical reflection. So there's quite a bit of homework for this lesson. So it's on 2 different pages in your workbook. So page 96 and page 103, because it corresponded to 2 different lessons in your workbook. And then here are your podcasts to watch, lesson 4, lesson 5. So make sure you have your podcast note package to do that. And that concludes this lesson.